Hello, I'm Mark Cooper. I'm a geologist with California Resources Corporation, and I'm here today to tell you about the three different groups of rocks so that when you start your own rock collection, you can know their categories. Our three groups of rocks are igneous, metamorphic, and sedimentary. What makes these three groups of rocks different is how they formed. Sedimentary rocks are formed from grains transported on the surface of the earth in rivers, lakes, oceans, sand dunes, and environments like that. The grains they're formed from could be sand, like this sandstone, or fine particles of clay, like this shale, or pieces of a coral reef, like this limestone. And they can contain fossils, like this sedimentary rock, which has fish bones. Igneous rocks are formed from a melt. Rock melts into lava or magma and slowly cools, sometimes in the subsurface and sometimes on the surface of the earth, and forms crystals of different minerals interlocking together. This basalt is formed from a common lava flow, and this pumice is formed from lava cooling quickly as it falls to the earth in a volcanic eruption. You can actually get some great samples of igneous rocks at your local hardware store. Most countertops are made of igneous rocks because they're cooling slowly from a magma, results in very hard rock. The third group of rocks are metamorphic rocks. Metamorphic rocks are formed deep in the earth under conditions of intense heat and pressure, but without fully melting the rock. They're like a rock that you baked in your oven from another rock, like a sedimentary rock or an igneous rock. Under these conditions of heat and pressure, the minerals in the rock slowly change, sometimes into different minerals, sometimes reorienting themselves, and form new and unique rocks. So these are our three groups of rocks: igneous, metamorphic, and sedimentary. Sedimentary formed from grains, igneous formed from a melt, and metamorphic formed under intense heat and pressure without melting. So when you start your own rock collection, you can group them into these three groups. Let's look specifically at one of these groups, sedimentary rocks. Sedimentary rocks can be formed from many different types of grains. This is a sandstone formed from sand that could be transported in a delta, in a river. And the sand grains in this sandstone are made of quartz, which is the most common sandstone. This rock is another sandstone, but it's formed from carbonate grains, such as limestone, in the Bahamas, where the beaches are made of limestone sand. You can see the layers in this rock, and these layers represent how it was deposited, with one layer of sand washing over another and over another as it's deposited over thousands of years. These two rocks are parts of our local Monterey Shale. They are formed from a small microorganism called diatomites. These diatomites live in the ocean, and their skeletons are made up of silica, just like quartz. This is a layered sedimentary rock from a local oil well that contains both clays and sandstones in layers. And you can see how these layers are contorted as they were deposited and water was escaping the structure under compaction as it was buried. Sedimentary rocks can also contain fossils. This sedimentary rock contains small fish vertebrae. And some sedimentary rocks can be formed entirely of fossils. This sedimentary rock contains pieces of a coral reef. In addition to sand, the other common mineral content of rivers and lakes washing into the ocean are clays. Clays form shales when they're deposited, typically further out to sea than sandstones. This is actually a piece of the Marcellus Shale, which is the greatest gas-producing formation in the United States, found in Pennsylvania, West Virginia, and neighboring states. It's called a black shale because it's very high organic content, which is what produces its natural gas. These are igneous rocks. They're formed from a melt of magma or lava that cools and produces interlocking crystals. The most common igneous rock is basalt, which is typically formed from lava flows, such as you often see in Hawaii. This basalt has a number of vesicles in it because as it was cooling, gases like carbon dioxide were bubbling out, and those bubbles were frozen in the rock structure. This is another basalt that had less gas content and formed less bubbles. If a basalt cools very quickly, it can form a glassy structure called obsidian, and it becomes an obsidian instead of a basalt because there's no time for minerals to form, and it is just made up of a glass that may have the same chemical composition as this basalt. The way that a basalt can cool very quickly is if it erupts under the ocean instead of on the surface. Just like if your hand got too hot, you might put it in water to cool it down. Erupting in water cools the lava more quickly and can form an obsidian instead of a basalt. In a volcanic eruption, we also have, in addition to lava flows, we have the explosive part of the eruption that can release ash. When that ash falls to the earth and cools, it can form a tuff. So this rock was formed from hot ash from a volcanic eruption that was welded together. An eruption in the air can also cool before it even reaches the Earth's surface. If it cools in the air with lots of hot gases escaping, it can form a pumice, which is a very light rock. This is a volcanic rock called a volcanic bomb that was caught by a coworker of mine during an eruption in South America. It has very interesting shining colors.
That's very cool. So that just like came down like a golf ball out of the sky and he grabbed it?
Like hail, rock hail.
That's so scary.
This is a rock from South Africa from the Archean era over 3 billion years ago that contains spherules. This was formed when a meteor impact struck the Earth and melted the rock on the Earth's surface. So anything that forms from a melt is an igneous rock. So in this case, it was melted by a meteor impact and formed these glass spheres as it fell back to the Earth. It looks like a sedimentary rock because these look like grains, but they're actually beads of melted rock.
So then, not DNA, but the structure of that, is that half Earth structure, and does it absorb some of the alien meteorite structure too?
There would probably be a chemical signature to that, but it would be, most of the composition of the rock. You got the whole Earth of local rocks, and then just a small meteorite with a lot of velocity. So you can get some great samples of igneous rocks at your local hardware store because igneous rocks form deep under the earth at high temperatures very slowly. They are very hard, durable rocks, so they make excellent countertops. But sometimes you can find the same igneous rocks in your local creek bed that you find at the hardware store. Our next category of rocks are metamorphic rocks. Metamorphic rocks are formed from other rocks under intense heat and pressure. They're not melted like igneous rocks, and they're not transported as grains on the surface like sedimentary rocks. Many metamorphic rocks, we can know which other rock they formed from. For instance, this is serpentinite. California's state rock. Serpentinite forms from a basalt. Basalts exist on the sea floor, and at our plate boundaries, they are taken down into subduction zones where they're mixed with water and heat. Add water and heat, and this rock, this basalt, becomes this serpentinite. This rock is a blue schist, which is related to serpentinite. This rock forms under particularly rapid subduction when it's pulled into the earth so quickly that it doesn't have time to heat up. So it experiences intense pressure without as much heat, which is a rare combination found only at certain plate boundaries, and it forms a blue schist instead of a serpentinite. Both of these rocks can be found around the northern coast of California, around Bodega Bay. These rocks are a quartzite and a schist, and these are formed from sedimentary rocks, which I discussed earlier. When a shale is metamorphosed under intense heat and pressure, it can become a schist as its clay minerals are transformed. When a sandstone is metamorphosed under intense heat and pressure, it can become a quartzite. And when you have a layered rock that includes layers of clay deposits and layers of sand deposits, a shale and a sandstone layered, you can get a layered rock with layers of schist and layers of quartzite. Many metamorphic rocks become layered when they're transformed under intense heat and pressure. So here you can see layers of different minerals in this metamorphic rock. They're not made up of grains like a layered sedimentary rock, but they're still layered. And this is often a way to identify a metamorphic rock. In this rock, layers initially formed during sedimentation on the surface have been squeezed into waves when this rock was metamorphosed. So, these are metamorphic rocks, formed under intense heat and pressure, transformed from other types of rocks without melting. So we have our three groups of rocks: igneous rocks, formed from a melt; metamorphic rocks, formed under intense heat and pressure without melting; and sedimentary rocks, formed from the transport of grains on the Earth's surface. Thank you for joining me to learn about rocks. I'm Mark Cooper, a geologist with California Resources Corporation. To learn more about California resources, visit poweringcalifornia.com or crc.com. Thank you.